Welcome to Module 3 of Level 3 Math, Fractions. This is the largest module in the course, but we have had a number of students come through this course and be successful at it, and they quite often surprise themselves once they start working through it. So hopefully that's your experience. As always, make sure you touch base with your instructors if you need help with anything. So let's start with 3.01, the Introduction to Fractions and Area Models. So most of you, pretty much all of us, have encountered fractions our entire lives. If you think about money, the term quarter, well, quarter is a fraction. There are 4 quarters in a dollar, so that 25-cent coin represents one piece of a whole dollar. If you had 4 of those, that would make up the whole dollar. There are rare cases where there's 50-cent coins, and those coins would represent, because 50 cents is half of a dollar, that's where the fraction 1/2 comes from. Again, others who've worked in trades or basically done any type of measuring, you've probably noticed measurements on a ruler or a tape measure are done in quarter inches, also 1/8 inches, 1/16, half inches. So pretty much everyone, if you're an adult, you've encountered fractions at some point in your life. But what we're going to look at is area models. Okay, so area models are pictures that represent fractions, and in this course, most of what you'll see would be square area models. However, we can make area models that are not square. So if we look at example 1, draw an area model for the fraction 3/4. Okay, so a fraction is meant to represent a piece of a whole. So if we want to do our typical square area model, let's say we have that. Think of it like a loaf of bread, if you will. Okay, so the fraction 3/4. Well, the bottom number, the 4 there, that's called the denominator, and that represents how many pieces the whole thing is broken up into. So if this was a model of a loaf of bread, that this bottom number tells us that a loaf of bread is cut into 4 pieces. Okay, so what we would do is try and do it relatively even, or better than I do at least. Okay, so we've broken it into 4 pieces, but now the top number, which is the numerator, that tells us how much is like the value of what we're talking about. So if we said we need 3/4 of a loaf of bread, well, we know that the bread is broken into 4 or cut into 4 pieces, but we only need 3 of it. So what we would do is shade in these 3 pieces. Okay, so if we look 3/4, we have 4 pieces, 1, 2, 3, 4, but only 3 are shaded. So 3 out of the 4, sometimes that's what that line can mean right there, is out of. So we have 3 pieces out of 4 possible pieces, and that's a fraction. And this is an area model. And I know it said that we're focusing mostly on square area models, but another way to do it would be to create a circle. And again, we know that the denominator is 4, so we want to divide that into 4 pieces. So maybe I cut it in half this way, and then cut it in half that way. And if we were going to represent, 3/4 on that, we would shade in 3 of the 4 quarters. Okay, and now we have our 1, 2, 3 pieces out of the 1, 2, 3, 4 possible. Another thing to note is we could do another square, and let's do a smaller one, and as long as the pieces are 4 equal pieces, then that is still an area model. So you could make your square kind of like this. I know that's not exact, but imagine that I was more accurate with that. Then we would have 1, 2, 3, 4 pieces, and then again we could shade in these 3 pieces. okay? And that would be 3/4 as well. Again, another one, we could do another square, and we could do the lines this way. And again, you're trying to go for equal pieces to represent, and then if we shade it in, 3/4 would be rough like that. Try and stay within the lines. My coloring skills are about the same as a primary student, but if you can forgive me, you'll notice that 1, 2, 3 of these 4 lines are colored in. So all of these different pictures represent 3/4. So let's look at another example. What fraction is represented by the area model on the right? Well, if we look over here, we know that, say this is our loaf of bread, first we need to know how many it's out of. So if we count how many total pieces there are, that will tell us our bottom part, or our denominator. So 1, 2, 3, 4, 5. So our denominator should be 5. So for A, we're going to put that out of 5. Okay? And now for the top part, the numerator, that's the shaded part. So that is these two pieces are shaded, so that would represent 2. So that would be our numerator. So the fraction represented by the area model on the right is 2/5. Okay? Now if we look at B, what fraction of the area model is not shaded? Again, it's still going to be 5 in our denominator, or our bottom. 1, 2, 3, 4, 5, because there's still 5 pieces in that area model. Okay? But the difference now is it says the area model is not shaded. Okay? So we have to look at the pieces that aren't shaded. So 1, 2, 3. 3 of those aren't shaded, so that becomes our numerator, or our top. Now, if we look at another example, it asks what fraction is represented by the area model on the right. So again, we're going to count how many pieces are there in this loaf of bread. 1, 2, 3, 4, 5. So that becomes our denominator, or the bottom. And how many of those are shaded in? Well, the whole thing is shaded in. So 1, 2, 3, 4, 5 are shaded in. So that's fine. You can have the numerator and the denominator be the same. And 5 over 5, this is basically equal to 1 whole loaf, right? So if you have 5 slices and each loaf is cut into 5 slices, you can make a whole loaf out of that. B, what fraction of the area model is not shaded? Well, if you look at it, nothing. So there are no pieces that are unshaded. So 0 becomes our top, and because still for our area model it's cut into 5 pieces, that's our bottom, so our denominator. Okay, so looking at this example, it asks us to create area models for the following fractions and then place each fraction by its appropriate arrow on the number line. Okay, so I'll save you the trauma of seeing my drawing for all these different fractions, so I've just got some area models down below here. And we'll just figure out which one represents which, and then we can just use the general look to kind of determine where they feel. So if we look at this first one, we need to figure out what the denominator will be by counting up how many pieces there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. So we're looking for a fraction with a 9 on the bottom. And we see it right here. The top, the numerator, tells us that there should be 1 piece shaded in, which there is. So we know that this piece is 1/9. Okay, now going to the next area model, we count again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the fraction that has a 12 on the bottom is here. If we look at the top, it tells us there should be 5 of them shaded in. If we go down, 1, 2, 3, 4, 5. So we know that this is our fraction, 5/12. Okay. Now if we go to the next one, again, 1, 2, 3 pieces total, so we know that the fraction with the 3 on the bottom is what it represents, and then the top, the numerator says that 2 of them should be shaded in, and there are 1, 2 shaded in, so we know that's 2/3. Okay, and then our last one, obviously it's going to be 1/9, and we can just 1, 2, 3, 4, 5. Oh, sorry, no, we've already got 1/9 over here. It's good. If we count it up, 1, 2, 3, 4, 5, 6. So it's got 6 on the bottom, and there should be 5 shaded in, and you can see 1, 2, 3, 4, 5 shaded in. Okay, so that's 5/6. Now, where to place them on the number line? Well, if you look, this number line represents, so 0 means there's nothing shaded in, and 1, a whole loaf, means that the whole thing is shaded in. A half would be approximately half of the square shaded in. So if we look down here, we can look and say, okay, well, this one has the least shaded in, this 1/9. So that's going to be the one closest to 0. So that's that arrow. So we go up here and we just put 1/9 up there. Okay. Next one, we go over here. This is pretty close to half. Fully half would be if this last piece was shaded in, because you'd have 6 out of 12, and that would be a whole half. So that would be 6 out of 12 would be right there. But because this is slightly less with the 5 up top, then slightly less than half is right there. So we're going to put 5/12 right there. Okay. Then we go to the next one. 1, 2, 3, 2/3. You know, half would be about here where this little light line is. So it's a little bit more than half, and that's where that arrow goes. So that's where we're going to put that. 2/3 is a little bit more than half. Obviously, our last one is going to be 5/6, but you can see that it's nearly a whole one, but not quite, because this last slice, if you will, is not filled in. So it's not quite 1, but it's pretty close, and that arrow is the closest one to 1. So that's how we could know that if it wasn't by elimination. Okay, so that's using area models to represent fractions. The keys to remember are the denominator, the bottom, tells you how many pieces a model is broken into, and the top, the numerator, tells you how many are shaded in, or the value of what we're talking about. Okay, if you have any if you have any questions, see your instructor.